Alright, good afternoon. So today what we're going to be doing, or tonight, we're going to be solving quadratic inequalities. Okay, so here's my example 1. I've got x squared minus 12 is greater than 3x plus 6. Unlike inequalities, quadratic inequalities, we will actually not be doing any shading on a graph. Okay, we also don't need to do too much work. I do not need to get this equal to 0. I don't need to move over the 3x or the 6. Instead, what I'm going to go ahead and do is I'm going to graph this side in y1 and this side in y2. Alright, so here's my graph. I'll go to y equal, put x squared minus 12, 3x plus 6, and then I'm going to graph it. Alright, so see here I've got a blue parabola and a red line, but I'm going to go ahead and zoom in, and knowing what I know I'm going to zoom in or zoom out 2 times. Okay. Alright, so now you see I've got a blue parabola and a red line going through it. So I think, alright, the important points must be the 2 points that they intersect. So I'm going to go to second calc. I'm going to go intersect, press enter 3 times. Alright, the first intersection is at -3. Now I'm going to find the other intersection. This time I'm going to move it over and 6. So my 2 intersections are -3 and 6. So now I'm going to go ahead and sketch a graph. So I had a blue parabola with a red line going through it at -3 and 6. Okay, so those 2 points right there are very important. To look at this, I'm going to draw a number line, put -3 on it, and I'm going to put 6. Okay, so now I go back to the inequality. This inequality says I want to know when the blue graph is greater than the red graph. Well, on a graph to be greater, that means it needs to be above. So greater, above. So when is the blue graph above the red graph? Well, I notice it's above here and above right here. So if I were to bring that down to the number line, that would be here and here. It wouldn't be in the center, because in the center it's actually below the red. Okay, so now I'm going to write 2 different notations here. The first notation is I'm going to use set notation, which is we're going to do inequalities to represent the answer. So this answer represents all numbers less than -3. So all numbers less than -3. This would be all numbers greater than 6. Alright, so there's one part of the answer. Here's another way to write that same answer. It's called interval notation. Interval notation uses negative infinity, positive infinity sometimes. In this case it is. It starts with the smallest number. Well, the smallest number that my answer is way down in negative infinity. So I'm starting with negative infinity, and then I start moving right. I stop at -3, and I close because there's a gap. So I'm going to put a little gap. I'm start back at 6 and go to positive infinity this time. So here's the 2 ways you can write the answer for this. So how did I get the answer? Is I looked for when the blue graph was above the red graph. So anywhere less than -3 and anywhere greater than 6. There's my answer. Okay. Which way do I want you to put the answer? Both ways, because you never know what they're going to ask for. Okay. The next example. I have x squared is less than 3x plus 6. So I'm actually looking at the exact same graph again. So I'm going to draw this graph again. again crossed at -3 and 6. So I'm going to draw a number line, -3 and 6. Okay, but this time it's asking when is the blue graph less than the red graph. Well, less means I'm looking for below. So less, below. So when is the blue graph below the red graph? Well, I notice the blue graph is below the red graph starting at -3 all the way to 6. So everything between -3 and 6. So the easiest way to represent this is using interval notation. So the interval notation answer would be from -3 all the way up to 6. If you were to write this in set notation, I'm looking at all numbers bigger than -3, but all numbers smaller than 6. Okay. So either one of these would be acceptable, but no, they're two different types. You wouldn't be asked for both. Okay. Alright, so my next example, I've got x squared minus 2 is less than -x minus 3. Alright, again, I'm going to put this in y1, this in y2. Okay, so let me turn my calculator on here. Go back to y equal. I have x squared minus 2 and -x minus 3. Graph it. Alright, so I kind of need to zoom back on this one. So I'm going to go back to zoom standard so I can see it better. Alright, so there's the blue parabola. Alright, and there's a red line. But wait, this one's a little different now, because now I'm noticing they're not intersecting. So what's that going to mean? Alright, so here's the sketch. I have the blue parabola, and I have a red line that's underneath it. Well, I need to know what it's asking me before I can answer it. It's asking me when is the blue graph less than, below. So when is the blue graph below the red graph? Well, the red graph's below the blue graph. So the blue graph is never below the red graph. Well, since it's never below, we have no solution. Okay? So I'm noticing because the blue graph is never below the red graph, I have no solution. Alright? So you will have some of those cases. Alright, so now my last example. I have 18a. Example 18a, you've got x squared is less than 2x squared. Alright, again, I'm not going to do anything but put this in y equal. Do the blue and the red. Okay. So x squared, so I'm just going to delete all this and then clear 2x squared. Graph. Alright, so looking at it, I notice it's intersecting, and it looks like it's intersecting right at the origin. Okay, so I'm going to draw this out. I had the blue one on the outside, the red one on the inside where it touched at the origin. So right here, they shared a point at the origin, so that's 0. Okay, so I can draw the number line again. But this time I'm only going to put the number 0. Alright, so now I go to what it's asking me. When is the blue graph below the red graph? So when is the blue graph below the red graph? Well, it's below all the way up to 0 right here. So all of this. And then same thing over here. All over here. So it looks like it may be all real solutions, because it looks like it's always below, but at 0. So here's two ways you can write this answer. all reals except x equal to 0, because at 0, they're equal to one another. I'm not worried about when they're equal. I only want to know when it's below. Or the other answer would be an interval notation, negative infinity up to 0, and then it will stop. Then it would start again at 0, all the way up to positive infinity. All right? And that would be your answer. Okay? So the goal when you're doing this is to just look at the graph and just look at what it's asking, draw it out, draw a number line if you need to, and that's it. See y'all tomorrow.